Welcome to the Explainer. Today we're practically strapping ourselves right into the flight deck of the Bombardier Q400. If you fly this incredible turboprop, you already know that flying an RNP LNAV/VNAV approach isn't just about pointing the nose at the runway, right? It's a highly choreographed sequence. It demands precision, a lot of anticipation, and strict adherence to your standard operating procedures. So in this explainer, we're going to break down that rigid sequence so you can really master the profile and perfect your approach.
Okay, let's dive right into this and build a quick mental map of our descent profile so you know exactly where we are at any given moment. We've got 1. Pre-approach checks and rules. 2. Activating the LNAV approach. 3. The Q400 flaps and gear sequence. 4. Final approach fix callouts. And finally, 5. Short final to minimums.
Section 1. Pre-approach checks and rules. Let's kick things off with the very first phase of the flight profile, well before we even commence the physical approach.
To make these mandatory initial rules totally effortless to memorize, I want you to just think of the acronym CPR. Check, plan, restrictions. Simple, right? First up, we check. You've got to verify those NOTAMs for any GPS outages and check your RAM prediction in the FMS flight plan page by feeding in your destination ETA. Second, we plan. You have to verify the approach is actually available and recalled from the FMS database. And crucially, you've got to cross-check it with your Jeppesen chart. Finally, restrictions. And listen, this one is absolutely non-negotiable. An LNAV/VNAV approach should only be used if it features one of 3 specific things: a published glide path angle on the jet plate, an RWX waypoint right at the approach end of the runway, or a missed approach waypoint located before the approach end. If you don't have at least one of those 3, yeah, you're not flying this approach.
Now there's a strict line in the sand here. If you're commencing or continuing the LNAV/VNAV and you see any of these navigation-related failures pop up, we're talking GPS INTAG, NAV INTAG, NAV DR, or literally any related caution light illuminating, you must abort. The rule here is incredibly strict. You have to discontinue the RNP approach immediately, unless of course you're in a position where the flight can safely continue visually.
Section 2. Activating the LNAV approach. With our CPR checks complete and our abort conditions clearly understood, let's transition to the next altitude phase. This is where the cockpit communication really begins to pick up the pace. And this brilliantly illustrates the critical 2,500-foot trigger. At exactly 2,500 feet, the radio altimeter essentially wakes up the final approach rhythm. The pilot flying, the PF, calls out, "Rad alt alive, set TCAS above." The pilot monitoring, or PM, then has a very specific set of responses. They recheck the QNH, set the TCAS to above, and announce back, TCAS above. It's a precise, verbal handshake right at 2,500 feet.
Next up, we establish our LNAV mode right before the intermediate fix. And there's this intricate back-and-forth dance between the 2 pilots here. The PF checks Activate Approach in the FMS nav page, and the PM verifies it. Then the PF selects the intercept heading and calls Intercept heading set, press Intercept. The PM then physically executes this by pressing line side key number 2 on the right in nav page 1 and announces LNAV heading intercept. Once captured, the PF calls LNAV heading to course, and the PM sets the heading bug to the course. Now, if you're crossing the intermediate fix within 90 degrees of the final approach course, it's actually going to activate automatically. The PF checks the MFD, ensures VNAV is available on the PFD, pushes VNAV, and calls VApproach. It's this highly structured, predictable rhythm that ensures both pilots are completely in sync.
Section 3. The Q400 flaps and gear sequence. We're moving into the critical configuration phase now, where managing your speed and your drag is absolutely vital.
Okay, the trick here is memorizing exactly when to dirty up the aircraft without busting your speed limits. I'm going to give you a super easy cheat code for this. Memorize the position triggers as 5, 1.51, and the speed stepping is 195, 167, 153. Here's how that actually plays out. At 4 nautical miles to the final approach fix, or 10 nm to the runway, you hit flap 5. Your speed must be below 195 knots. Next, at 1.5 dots from the top on the V approach, you drop the gear. Again, speed below 195 knots. Then at exactly 1 dot, you call for flap 15. Now your speed gate tightens up. You've got to be below 167 knots. And finally, if you're briefed for a flap 35 landing, you wait until that landing checklist is complete, ensure your speed is below 153 knots, and select flap 35. So it's 5, 1.51 for your position, 195, 167, 153 for your speed. Just keep those numbers locked in your head.
10:20.
I want this number to just be a complete visual pattern interrupter for a second. Ask yourself, what does 1020 stand for? Well, right after flap 15 is set, the PF announces condition levers to max, and 1020 RPM, that's your max setting. The PM sets those condition levers to max, and immediately after, the PF calls for the landing checklist. So from now on, whenever you think of dropping to flap 15, I want you to immediately think of pushing those levers right up to 1020 RPM.
You know, in aviation, the tolerance for late configuration is literally zero. Your base landing configuration must be completely finished by the final approach fix. There is absolutely no wiggle room there. On top of that, if you're doing a flap 35 landing, that selection has to be made at the absolute latest by 5 nautical miles or 1,500 feet above ground level depending on the surrounding terrain. Bottom line, don't fall behind the airplane.
Section 4. Final Approach Fix Callouts. Let's shift our focus to the Final Approach Fix, which is a massive geographical and procedural milestone for us.
Now, what's really interesting about this is how the callouts completely shift depending on whether you have vertical guidance available at the FAF. When you cross the FAF on an LNAV/VNAV approach, the PF confidently calls out LNAV VNAV approach capture, and the PM echoes it right back. But if you're stepping down on an LNAV-only approach, it's a different story. The PF calls out LNAV VS for vertical speed. And because you don't have that automated VNAV path holding your hand, the PM has to take on a way more active role. They have to give mandatory DME versus altitude callouts to make sure you're safely tracking that descent profile step by step.
Section 5. Short final to minimums. All right, the gear's down, the flaps are set, we've passed the FAF, and we are officially bringing you into the final high-stakes moments of the descent profile.
Let's just walk through this short final timeline chronologically, because it happens fast. At 1,000 feet, height above touchdown, the PM glances at the radio altimeter and calls out 1,000 FT. The PF has to verify the approach is fully stabilized and replies, stable continuing. As you drop down to 500 feet, the PM checks the panel, making sure those bleeds are set to min and off. Getting really close now. The PM is watching that barometric altimeter like a hawk. At 100 feet above the minimums, if the visual cues are there, the PM calls 100 above minimums, runway in sight. And the PF acknowledges with check, continuing. And then you hit the ultimate trigger, minimums.
At the decision altitude, the PM calls minimums. This is the ultimate decision point. If the PM adds runway in sight, the PF commands contact landing. But if that call is minimums no contact, the PF's immediate absolute muscle memory response has to be go around. Adhering to this rigid sequence, from the CPR checks to those 1020 RPM condition levers, right down to the wire with these final callouts, is exactly what guarantees a safe conclusion to the flight. It keeps you ahead of the Q400 rather than desperately chasing it down the glide path. So the next time you're prepping for that RNP approach, I leave you with this question. Are you commanding the automation, or are you letting the automation command you? Thanks for joining me on this explainer. Keep those speeds locked in, keep your callouts crisp, and I'll catch you on the next one.